My name is Daniel again, and today I'll be talking about the Tidier ecosystem about 2 years after we first released it. Basically everything in this talk you can just do if you say using Tidier in your terminal. About me, kind of the same faces. I'm still a doctor. I'm still here at JuliaCon, and my first experience was still learning code in 2023. All right. So before Karandeep's keynote back a couple days ago, he gave this talk at JuliaCon in 2023 doing some myth busting around like the tidyverse, right? And at that time, we were introducing it into Julia, and the first thing is that tidyverse is not standard R, and I think that's a common misconception. It's actually more of a philosophy around tabular data wrangling, manipulation, and visualization, right? To the point now where it exists in multiple languages, Python, R, JavaScript, Julia, like really you name it, somebody's tried it. And so at that time, it was really just TidierData, and that was just kind of a manipulation that was based on DataFrames.jl. And it's now grown to be more than 10 packages, and it's pretty comprehensive. It lets you work with data frames as well as to do transformations, reshaping, visualization, databases, web scraping. Really, it's pretty all-encompassing. And so just to kind of take a step back here and kind of talk about my own path into coding, right? In 2023, I first learned how to work with tabular data using like dbplyr and dplyr and R in Karandeep's class. And I remember when I learned that, I was like, wow, I don't ever want to use Excel again. That is a horrible place to live. And so I really enjoyed that experience. And then, a couple of weeks later, whatever, I had another class where I had to use Python to do some natural language processing. And I found at that point, I didn't know about these packages, and I was trying to use pandas to do my data wrangling, and it was a horrible experience. Okay, like I'm sorry to say, but it made me never want to use Python, and there was just like a lot of friction there, especially on packages. And then, moving forward, now we have TidierData and TidierDB and TidierPlots, right? And so I think that really what is, really neat and important here is that like a shared philosophy reduces activation energy, right? So if you know how to wrangle your data in R, you can now do it in Python, you can do it in Julia, and vice versa, right? So folks who may be interested in trying Julia can now kind of take out some of the friction and kind of resistance that they may interact with to get their data into the shape that they actually need, right? Because when it comes down to it, a lot of data analysis is it's a lot of cleaning data. So what are the core principles of Tidier? The first thing is that it's a comprehensive data analysis meta package, right? We want you to be able to, jump into Tidier and have everything you need included, right? So it's batteries included. We want chainable, readable pipelines via chains and .jl, which is a kind of a great underlying package. And we kind of default to using a high level of abstraction that's done by leveraging macros. And then lastly, again, it's just leveraging this kind of shared philosophy across multiple languages. So to just jump right into some of the packages, Tidier files, it really just builds on a lot of the excellent work that people in the Julia community have done across, CSV.jl, Arrow, JSON, like you name it, folks have built it and it works. And all we really did here was just harmonize the keywords across all these different file types. So that way, it's just kind of like one step of friction to get out of the way. And you can use the read file, write file, and auto-detect the backend needed, or the function needed, and dispatch it for you. So now to jump into TidierData. So this is built on the excellent DataFrames.jl package, and it uses macros so you can kind of use bare column names, which I think is something that's a little bit atypical in Julia, but it is used kind of throughout various places. It also leverages auto vectorization and I'll kind of touch on that and why it's actually so important. And it's all encompassing, right? You can join, pivot, meaning like go to wide from long to wide. You can aggregate, nest or unnest your data. And really, I know this is kind of again chaotic, but these are all the top level macros it supports. So we want to make sure that when users are using it, they don't actually have to fall back on DataFrames.jl if they don't need to. And of course you can, right? You can throw in a DataFrames.jl function in the middle of your chain. It's actually really nicely, easily integrated, right? And then we also have all these kind of helper functions in TidierData as well. So this is just an example. In this particular example, I used pipes to compare the data frames to a TidierData chain. But you can see that in the difference, right? That anonymous functions are kind of happening behind the scenes, and so that's one thing that's happening, right? The vectorization is, again, it's implied within a lot of the functions, and you know, it's just a little bit more, I think, readable or accessible to people who are maybe less familiar with coding or less familiar with Julia, and you know, it's just can kind of take away some of that cognitive burden, right? So if you come back to your code later after doing some sort of data analysis, you can kind of jump right back in and figure out, oh, I was doing X, Y, or Z. And here you'll just notice that mean is, we don't need to tell it not to vectorize it, it knows not to. So I think my understanding about the Julia community is we love benchmarks. And so just briefly on the benchmarks, looking at TidierData compared to DataFrames.jl on like 9.4 million rows, give or take, there really isn't a substantial difference. I think the only place that we really see a difference is in this group by and then mutate when you're kind of putting in 2 new variables or more, right? But outside of that, there really isn't any sort of penalty that's significant, right? This is time in milliseconds, and I personally, I work enough at work that I can sacrifice 10 milliseconds, and that's okay. But it is something that we hope to address moving forward. And I think that logging is actually one of the coolest aspects of this entire package. So Randy Boys kind of kicked this off, and this was always something we wanted to do. This is based on the tidylog package in R. So when you're working with a data set, it's really important to have a foundational understanding of the content of that data set, right? You can't just kind of clean it without understanding it, right? So in this example, we'll use the movies data set. And the first thing we're going to do is we're going to filter by year, right? And of course, we've set tidier set data set to true, right? And you can see this filter right here has removed 85% of your data frame, okay? And that now you only have 8,700 rows remaining. That is a significant portion. If you didn't know that moving into your data while you're working with it, you can end up kind of eliminating large swaths of data or kind of having, for lack of a better word, silent errors occur, right? And so again, this is an option that you have, right? If you're mutating in a new variable, it's gonna tell you how many unique values are in it and then what % of that column is gonna be missing. If you're summarizing it, it's going to tell you, you know, how many rows. So it's just really, it adds a lot of color to the process of data manipulation and cleaning and wrangling, which I think is important in good analysis. Now, as far as the auto vectorization and why it's important, so TidierData uses a lookup table to decide what to vectorize and what not to vectorize. And the reason this matters is because it lets us, as we'll kind of talked about before, I'll touch on it again briefly, it lets us go to SQL, right? So if you, for example, have mean here and you wrap it as a new mean, new function, right? And you call it as a new column D, you'll see that it's wrong, right? Because that's just not how it should function. But if you want to, you can actually choose not to vectorize it by putting a tilde in front of the function. And then TidierData will know, okay, this function should not be vectorized. And on top of that, we wanted to make sure that users maintain full control. So if you like to use dot broadcasting and you want to see where your dots are, you can add all those to your data and it will still work, right? It's not going to be an issue. So as we talked about briefly, maybe there's a couple new faces in the room. If you don't have a data frame, it's not a problem, right? Once you know tidyData and you can work on data frames like that, you can now work on databases with no issue. And again, this is, I think, a kind of relevant picture because we see that the syntax order and the semantical order for SQL are not the same. And it creates tension, right? If you've done your initial kind of exploration on a small subset of your data, now you need to move to SQL because the bulk of your data lives on a database, you have to essentially start from scratch if you don't know SQL or, you know, kind of work in a whole new way, right? So again, what is TidierDB doing? It's converting your TidierData code to SQL. This is not one of those like gotcha spot the difference pictures. I'll make it big so you can see it. It's really just collect. Outside of that, the code is identical, except for like reading in the data, obviously, or kind of getting it ready. But everything else, you know, you can see is there is no difference. And I think this is one of the really beautiful things here because once you can do one, you can do the other. And that can save people a lot of time as well. And so, to summarize again, it's lazily writing the query, right? So in this example, you might notice that there's a lot of common table expressions. And This was how I had to figure out a way to safely move from TidierData code to TidierDB. And I wrote about 100 tests with multiple step transformations comparing the TidierData to TidierDB to make sure that there was no difference in outcomes, right? And so they are all the same. And again, it supports 12 backends. I want to stress too that DuckDB is the only backend that comes within the package. The rest are all extensions to try and lighten up the overall dependency load, and then supports all the native functions, aggregate function, user-defined functions, and more. In this example here, we have the fish data set. You know, it's kind of a toy data, but this is in the long format, right? So sometimes if you want to do kind of easier visualization, you have to go from long to wide. We can use pivot wider for that, and pivot wider we do, right? So here we're reading in the data. We can see we do pivot wider, names from station, values from value, fill, missing. And this is the TidierData code. And then down here, we have the TidierDB code. And again, there's no difference between the two except for adding this collect. The one caveat here I'll say is that pivoting is actually an inherently eager process where you need to know the distinct values for the column, right? And so what I actually did here is it's optional. If you already know what the values are, you can give it a dict and it will not do any kind of additional execution. If you don't know, it'll just run a simple query behind the scenes, pull the distinct values for the column it needs, and then it'll write that SQL query for you, right? But in essence, you have like the entirety of TidierData at your disposal in TidierDB, plus all your SQL functions. Moving into Tidier plots, this is Randy Boyes has done a lot of excellent work here. I should say Current Deep really did the incredible parsing that's in TidierData, and so I want to shout them both out. So Tidier plots is combining the power of Makie with ggplot. Okay, so ggplot is kind of a very famous, well-known, well-loved, well-used package in R for data visualization. It's been re-implemented across the board, and it works in building layers, which we'll show in a second. Okay, and Randy gave a talk, I think, yesterday as well. So it has a lot of geom supported already. You know, you can do kind of bar-like plots, scatter plots, lines, error distributions. You have all these different scales available to you. You can easily leverage color schemes.jl palettes. And this is as a quick sidestep here. If you're interested in contributing, I think geoms are a really nice way to kind of dip your toes in. Randy has an open issue on the Tidier plots GitHub that you can jump into. It's a nice self-contained project, and we would love some new contributors as well. But let's just go into it, right? So we have the empty cars data set. You know, we want to make a scatter plot looking at horsepower against miles per gallon. We're going to start our chain, and you don't have to do that if you don't want to, but the chain will be relevant later. So you have your ggplot, and then your AES macro is to establish the aesthetics. And these will kind of go for all of your subsequent geoms, but you can also do individual geoms by just putting that AES within it, right? We want X to be HP, we want Y to be MPG, and then we want this to be a point, or like a scatter plot. And then for our labs, we want title to be equal to fuel economy, Y is MPG, X is this, and then, you know, have a minimal theme, okay? But what if we wanted to add like a smooth linear regression line to it? We can do that. The only thing we're gonna add here is just plus sign, geom smooth, method equals LM, and then now, right, we now have our line you can see, and it's right there, and it looks great. Okay, but I know there's a lot of folks here who don't use miles, and I wish that we used the metric system in America too. So what if we wanted to convert MPG to kilos per liter? You can do that, right? The AES macro uses TidierData under the hood, so the anonymous functions all happen behind the scene. MPG times 1.61 divided by 3.78. Now we have kilometers per liter. We change it in the Y title, and there it is, right? So now you can see the graph has changed. And if you really like anonymous functions, you can still use the AES function. Randy has functionality for both, and you can write your anonymous functions that way. All right, and the reason I've been using chain in these examples, even though I didn't need to, you could have just started with ggplot, empty cars, and go from there, is because one of the things that's really nice is when you're doing data exploration, you may need to make changes, and you're kind of making changes to your graph, making changes to the actual wrangling that you're doing. And the nice thing is when you say using Tidier, you can do that all at once, right? So in this example, we'll use the flights data set, and we're going to clean the names. We're going to mutate in, you know, we're going to floor the hour per day, and then we're going to get the days of the week. And we'll kind of continue on to where we use cat relevel, which is from tidy cats, just to kind of like make sure the order of the categorical variables are all in the same. And then finally, we'll group by, summarize, and then get to our plot here. And we have a nice tile plot that shows when are flights most likely to be canceled. And again, like, I think what's really nice here is you have this really nice interplay between TidierData and ggplot, right? And this is also, I mean, this applies to TidierDB as well, right? If you use TidierDB to do your data manipulation, then you collect it, you can just jump right into a plot, or plotting from that same code, right? And the only other thing I forgot to mention is that in TidierDB, or TidierData, CurrentDeep wrote some really cool metaprogramming under the hood, so that way these are dispatched all the same. Like the macros actually know which one that needs to be used. You don't need to do any additional decorating when you're using TidierData, or Tidier, excuse me. So, we continue. Randy, he took it one step further. Makie's it's an excellent place to plot as well, and they have a lot of cool functionality. So if there's a particular geom that hasn't been implemented, you can implement it yourself, right? So here he shows an example. You want to make a rain clouds plot that already exists. You can do that, and just with this one line of code, you've now created your own geom, and then there it is. You can now use it and immediately jump into using additional features from Makie. He also made it so that it works nicely with plots, right? So here we have an example where if you want to kind of leverage this idea of patchwork as well as plot layouts, you can do all of that. Tidier dates, I'm just going to be brief on this one. This really just leverages dates.jl plus some kind of custom parsing under the hood. If you all have ever worked with survey data, sometimes people will leave the date box as a free entry text, and then it's a nightmare to clean that, and you wonder, why would you do that to me? And Tidier Dates hopes to kind of address that on some level, right? So it will basically try and figure out what the most likely dates.jl format it is, and if it can't figure it out, it has a custom parser on the back end to actually clean that up, right? So like if somebody had written December 3 RD, 2020, it'll know how to clean that up and get that. I did some benchmarking as well on this, which I don't have here, but it really is, there's no significant penalty for it as well, right? So there's not a sacrifice here. Tidier Vest. This was Jose Diaz. I think he's out in Denmark. He made this really cool web scraping package that's based on the rvest R package, okay? So this is an example where we are taking the highest grossing films, and then we're going to look at the HTML elements, and then we're going to make it a table. And again, this is an example where like, oh, hey, I know I need to get this turned into a data frame. You can do all of that kind of within Tidier, and it's like in a nice, neat, easy to kind of read and follow way. And I think that most of these movies are mid. This is another example that Jose sent me to include. He actually made a website, he made a website that leveraged Tidier Vest. So he wanted to take the Steam games website and like make it so that way you could have another website that has a list of all these games. And kind of this is an excerpt from his code base, and you can see that they're actually, scroll and get was a custom one he wrote, but HTML elements and like the parse HTML, these were things he wrote so that way, these are both from TidierVest, excuse me, but this he wrote. So that way you would kind of scroll down and would click, and then now he has a website that has basically done the web scraping for him and is making like lists based on countries. It's pretty cool. Where you can check it out. Tidier iteration. This was by Vituri da Silva. He's out in Brazil. I'm grateful for his work as well. This is based on the per package in R, which albeit I'm a little bit less familiar with, but it is very well loved and really powerful for like applying functions across different objects, and so now it brings that to Julia, so you can kind of easily do arrays, dicts, and more. And so you can see here he's flattening nested dictionaries, and there's another one that's not defined up here, but it's kind of taking out maybe some of the pain points as well. Here's another example. There's a function there that's called possibly, where instead of a chain or a pipeline failing, it will kind of have a predetermined value it puts in for those failed ones. Tidier text. This is a package I wrote kind of as a challenge. And this is based on the tidy text package in R, which is used for text mining, right? Sometimes when you're doing text mining, like let's say you have a whole bunch of different books and or like, I don't know, news articles, and you want to clean them up and you need to get your data into like a tidy format. This will tokenize your data and make it into a tidy format. So that you can more easily plot it, right? So we're seeing here, like leadership laboratory, you have your ID, it's made to lower, and there's just like that, so you can kind of do whatever graphing you need to do. A couple of honorable mentions, tidier cats. This is just for working with categorical variables, particularly when plotting. Sometimes you need to lump your categories into new categories. You want to relevel them, you want to reverse the order. There's various reasons that you'd want to do that while you're plotting, and this is just trying to simplify that and kind of take out some of that cognitive burden associated with remembering things. And tidier strings is a convenience function for working with strings. So what's on the horizon? Tidier 2.0 is hopefully coming out soon, in the distant future when we get tidier DB plots and data to their 1.0 releases. CurrentDeep has been putting in a lot of cool work to tidy your course to familiarize folks with the kind of thinking that goes into it and some of the gems that we have tucked away in these packages. And then we're translating, hopefully soon, a well-known epidemiology handbook from R to Julia as, again, just like another point of entry for folks. So with that, thank you to all these different people. There's been a lot of contributors, and we're grateful for all their work. I won't name them all. You can find us in the Slack channel, or you can go follow us on Blue Sky and become a contributor. Thank you.
Okay, now let's see. Any questions for Daniel? Oh, okay.
Thank you for the talk. From an outsider view, Tidier and Julia just appeared out of nowhere at some point. Do you have some elevator pitch for the story of how this happened? That's a lot of people, and the Julia community is not that large.
Yeah. So this kind of CurrentDeep is the one who started it all off. He's the one, the guy who gave this speech a couple days ago, or like the keynote talk. And basically, he's always really liked R, and he's used it a lot. And he was trying to find a new language, and I don't think he loves Python. And so I think it was December 2022. He read the entirety of Bogomil's book, DataFrames, the introduction for data analysis. And he was like, "Wow, this is awesome." And then he started playing around with it, writing tidier data, and just to see can we kind of bring this to Julia, because Julia is a lovely language to write in. And then shortly thereafter, I think Randy kind of connected with him and wanted to work on tidier plots. And at that point, I was a student waiting for some data to come through, and I was just like, I wonder what I can contribute to. And then the next thing, we kind of just rapidly, it's kind of snowballed. And so our hope is really that we can just give people a new point of entry for Julia, because I think that there's a lot of people out there who would really like the language. I know for me, when I've written it, it's much nicer to read than both R and Python. And I think that there's a lot of people who might be more interested in trying things out if they know they don't have to learn a whole new way to wrangle data.
Hi, thanks for the talk. Every time I install DataFrames, I install DataFrames Meta because it's way easier, and it seems something related to this. Can you please provide some small comparison about the two approaches in TidierData and in DataFrame Meta? And the second question is, this repository, TidierData, depends only on Julia, is 100% Julia code, or it has some external dependency of other libraries?
Everything is written 100% in Julia. Obviously, we use the DataFrames.jl package for that, but everything is 100% Julia. So thank you for reminding me to say that. I totally forgot. As far as the DataFrames meta, I think when CurrentDeep started, he took inspiration from it, but there was some challenges to it, right? Like, for example, I think that if you want to have it use a vectorized macro, you have to use R transform, for example, versus the transform macro. And then on top of that, you're still using symbols, I'm pretty sure, for the column names, and you're still having to use anonymous functions. So early on, our goal was really to stay as true to our syntax as possible, which meant bare columns and no anonymous functions. And that was something that was not actually possible with DataFrames Meta as well.
I'm starting to see the need to store tables in some maybe non-traditional formats. For example, HF5 or JLD in the Julia.io organization, or maybe things like SAR. I was wondering, where's the best place to kind of start making these connections to these other kind of binary formats?
That's a question I think CarnDeep would be able to answer better than me. I'm less familiar with those file formats. I'll just be upfront about that. You know, I think that, is there a tables.jl interface for those or no?
I don't think so.
Okay.
So and on one hand, I'm tempted to just start it by myself and kind of figure out how to do the mapping there. I'm also trying to be conscious of like what might exist beforehand, but this is just something that I've started to see recently because I'm using these for like n-dimensional or chunked data. But then people want to put tables in these formats for some reason. So.
Yeah, I think that probably the best place or like the ideal would be if there's a tables.jl interface. I know that was actually one of the pain points with TidierDB, right, is that there wasn't a tables.jl interface for SQL. So I had to like custom write everything, and I ended up just abandoning trying to write the tables interface because there's like SQL complexity and nuance that I couldn't capture as fast as I wanted to. So maybe that would be the first place to start. I think that would be it, yeah. Sorry if that's not satisfying. Yeah.
Anybody else? Oh, I have a question myself. You have a medical background in this.
Yeah.
I spent a lot of time with databases that are actually from Epic. Actually implemented a lot of the database that they use, Cache or Iris.
Oh, incredible.
Database. But I didn't see any connections to the Cache or Iris database. Or is that something that maybe someone could come up with that might be useful?
Are those written, you use SQL on those?
Well, most of the EHR data in the US is stored in those databases.
Okay.
That Epic Air uses.
Right, because I know for us, the Epic databases, I think they use SQL as well, like we're at University of Maryland. I'm not totally sure. But I think that, how about this? I will learn about that, and I'll open an issue.
Well,
yeah.
Maybe if you're hackathon tomorrow, we can talk about that.
Sounds good, thank you.